National Electrical Code, commonly referred to as the NEC, provides guidelines to ensure electrical safety. One key aspect is limiting the total connected load on a circuit breaker. For continuous duty, the NEC limits the total connected load to 80% of the breaker's rated capacity. This is a crucial safety measure to prevent overheating and potential fire hazards. Continuous duty refers to a load that operates for 3 hours or more at a time. If you exceed the 80% threshold, you risk tripping the breaker frequently or, in more dangerous scenarios, overheating the wiring. For larger loads, demand factors are sometimes employed to reduce the calculated load, potentially allowing for more outlets on a single breaker. Demand factors account for the likelihood that not all devices connected to the circuit will be operating simultaneously at their maximum power draw. However, demand factors should be applied judiciously and in accordance with NEC guidelines. In the planning phase, when the exact usage is uncertain, a practical rule of thumb is to estimate each outlet drawing approximately 1.5 to 2 amps. It's important to understand that this is an estimated range. The actual amperage draw can vary significantly based on the types of appliances and devices connected to the circuit. Small electronics like phone chargers draw very little current, while larger appliances such as hairdryers or space heaters consume considerably more. To estimate the maximum number of outlets permitted on a breaker, you can divide the breaker's capacity in amps by the assumed amperage draw per outlet. This calculation should also incorporate the 80% safety factor mandated by the NEC. For example, to determine the number of outlets on a 15 amp breaker, you would divide 15 amps by 2 amps per outlet. This calculation yields 7.5 outlets. Because you can't have half an outlet, it is recommended that you install 7 outlets on a 15 amp breaker, assuming a load of 2 amps each. Now let's consider a 20 amp breaker instead. Using the same principle, you would divide 20 amps by 2 amps per outlet. This calculation yields 10 outlets. Therefore, you could install 10 outlets on a 20 amp breaker, assuming that each outlet draws a maximum of 2 amps. It's crucial to remember that these calculations are based on estimations. The actual number of outlets you can safely install may be lower if high amperage appliances are connected to the circuit. Always account for the potential load of every device that will be used in the circuit. Another critical consideration is the wire gauge used in the circuit. Larger gauge wires have a greater current carrying capacity and can safely support more outlets. The NEC specifies the appropriate wire gauge for different amperage ratings to prevent overheating. When selecting wire, consult NEC tables such as Table 310.15b16 to determine the correct size based on the circuit breaker's amperage and the wire's insulation type and temperature rating. It is important to choose the correct wire gauge. If you use a wire gauge that is too small, you are at risk of overloading the wire and causing a fire. Furthermore, the type of wire also makes a difference in the amount of amperage it can carry. THHN wire is a common type of wire used in residential wiring. However, there are other types of wire available as well. Each type of wire has its own specific temperature rating and amperage capacity. You can also use aluminum wiring in some cases. However, aluminum wiring has different properties than copper wiring. It is essential to use the correct connectors when working with aluminum wiring to prevent corrosion and potential fire hazards. Always consult with a qualified electrician for specific calculations, design recommendations, and to ensure compliance with local electrical codes. Electrical work can be dangerous, and it's essential to have the expertise of a professional to ensure the safety of your home and family. Now let's consider some additional factors that can influence the number of outlets you can safely connect to a breaker. Firstly, the type of load is a significant consideration. Resistive loads, such as incandescent light bulbs and heaters, draw a relatively constant amount of current. Inductive loads, such as motors and transformers, can draw a significantly higher inrush current when they start up. This inrush current can briefly exceed the breaker's rated capacity, potentially causing nuisance tripping. If the circuit will primarily serve inductive loads, it may be necessary to reduce the number of outlets to accommodate the higher inrush current. Secondly, the length of the circuit also plays a role. Longer circuits experience greater voltage drop, which can reduce the performance of connected devices and increase the risk of overheating. The NEC specifies voltage drop limitations for both branch circuits and feeders. If the circuit is particularly long, it may be necessary to increase the wire gauge to minimize voltage drop and maintain safe operating conditions. Thirdly, the ambient temperature can affect the current carrying capacity of wires. At higher temperatures, wires become less efficient at dissipating heat, which can reduce their ampacity. The NEC provides correction factors for ampacity based on ambient temperature. In hot environments, it may be necessary to reduce the number of outlets or increase the wire gauge to compensate for the reduced ampacity. Fourthly, consider dedicated circuits. Dedicated circuits are used to supply power to a single appliance or piece of equipment. Dedicated circuits are commonly used for refrigerators, freezers, washing machines, and other high-power appliances. Dedicated circuits can help to prevent overloading and ensure that these appliances receive the power they need to operate safely and efficiently. It is important to properly label all circuits in the electrical panel to identify which appliances are connected to each circuit. Fifthly, arc fault circuit interrupters, commonly known as FSIs, are a type of circuit breaker that protects against arc faults. Arc faults are dangerous electrical conditions that can cause fires. FSIs are required in many areas of the home, such as bedrooms, living rooms, and dining rooms. When planning your electrical system, you must account for the cost and installation of FSIs. Sixthly, ground fault circuit interrupters, commonly known as GFCIs, are another type of circuit breaker that protects against ground faults. Ground faults occur when electricity flows through an unintended path to ground, such as through a person's body. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Similar to FSIs, when planning your electrical system, you must account for the cost and installation of GFCIs. Seventhly, consider future expansion. When planning your electrical system, it is always a good idea to anticipate future needs. Consider whether you may need to add more outlets, circuits, or appliances in the future. By planning ahead, you can avoid the need for costly and disruptive electrical work later on. Eighthly, understand local codes and regulations. Electrical codes and regulations vary from one location to another. It is important to familiarize yourself with the local codes in your area to ensure that your electrical system complies with all applicable requirements. Your local building department can provide information on electrical codes and regulations. Ninthly, consider surge protection. Surge protection devices can help to protect your electronic equipment from damage caused by power surges. Power surges can occur due to lightning strikes, utility switching, or other electrical events. Surge protectors can be installed at the electrical panel or at individual outlets. Tenthly, think about energy efficiency. When planning your electrical system, consider ways to improve energy efficiency. Using energy-efficient appliances, light bulbs, and other electrical devices can help to reduce your energy consumption and lower your electricity bills. There are many resources available to help you learn more about energy efficiency. Firstly, the NEC's tables for conduit fill. This means that the NEC specifies how many wires can be placed in a conduit of a certain size. This is to prevent overheating of the wires. Secondly, the NEC requires that all electrical work be performed by a qualified electrician. This is to ensure that the work is done safely and correctly. Thirdly, the NEC is updated every 3 years. It is important to stay up to date on the latest changes to the NEC. Fourthly, the NEC is a complex document. It is important to consult with a qualified electrician to ensure that you understand and comply with all applicable requirements. Fifthly, the NEC is not a substitute for good judgment. Even if you comply with all of the requirements of the NEC, it is still important to use good judgment when working with electricity. Sixthly, the NEC is a living document. It is constantly being updated and revised to reflect new technologies and best practices. Seventhly, the NEC is a valuable resource for anyone who works with electricity. It provides a wealth of information on electrical safety and best practices. Eighthly, the NEC is a collaborative effort. It is developed and maintained by a committee of experts from various fields. Ninthly, the NEC is a consensus standard. This means that it is developed through a process of consensus among interested parties. Tenthly, the NEC is a widely adopted standard. It is used in many countries around the world. It is important to use common sense when working with electricity, even if you are following the NEC. Always turn off the power before working on any electrical equipment. Never work on electrical equipment when you are wet or standing in water. Use insulated tools when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, but if you take the proper precautions, you can work with it safely. It is essential to follow the NEC guidelines and to use common sense. If you are unsure about anything, consult a qualified electrician. The NEC is a valuable resource, but it is not a substitute for good judgment and professional expertise. When you follow the NEC guidelines and work with a qualified electrician, you can ensure the safety of your electrical system. It is also vital to check with your local jurisdiction to see if there are any additional requirements. Local amendments to the NEC may exist, and they are important for you to know. For example, a city might require that all new construction include arc fault circuit interrupters on all 120-volt circuits. In summary, determining the appropriate number of outlets per breaker requires careful consideration of several factors, including NEC guidelines, estimated amperage draw, wire gauge, and potential future needs. Always prioritize safety and consult with a qualified electrician to ensure compliance with all applicable codes and regulations.